Hello, hi, I'm Terence. I am from Off-Chain Labs. I am an Ethereum code developer. I work on Prism. So today I want to talk about how EIP-7732 EPBS redefine Ethereum. So I want to start the talk first by saying scaling is the primary number one priority, right? You have seen this multiple times on the internet, even in the blog posts in the EF, that scaling is the most important thing that we can do today, right? And then we did that last year. We shipped Peer Dust last year, December 2025, that changes how we scale data availability. And I want to say we're going to do this again this year in 2026, which will fundamentally change how we scale two things. The first is DA. The second is execution. So we're going to scale more this year. So how are we going to scale? So Peer Dust, what we shipped last year, scales DA, and then it uses erasure coding, polynomial commitment, something that I would say probably 99% of this audience probably not super familiar, but it works, and that's all it matters, right? And EPBS kind of scale Ethereum differently. This is through pipelining, and this is something that's so simple that everyone in this audience will be understand at the end of this talk. I promise you. And yeah, so basically something we'll get through more. So before we talk about scaling, let's ask today what is the bottleneck, right? To run a node, we don't want to sacrifice decentralization. We want everyone to be able to run a node, even your internet is 100 megabits per second, you have say a Raspberry Pi, you should be able to run a node, right? But what's the bottleneck? Bottleneck is that you need to download the block. You need to download three things: the block, the payload, and the blobs. And those are very bandwidth heavy. Then after you download them, you need to verify them. You need to verify the block, you need to verify the payload. Payload here are the execution stuff, like basically what the EVM does, right? Bandwidth is the most important part, is the most expensive thing. Compute is the second most expensive thing. And here is the Ethereum slot. Basically what I said in the last slide, let's translate this into a diagram, right? You have 4 seconds to do everything. You have to download the blob, you have to download the block, you need to verify everything. If the block passes the 4-second mark, then the block gets reordered. It becomes a missing slot. The whole 12 seconds is missed. So why is bandwidth a bottleneck today? Because bandwidth contradict with scaling, right? Because the more you want to scale, the bigger the block size is. There's no way around it. And the bigger block size is, the more your node has to download everything. And surprisingly today, the consensus part of the block is only 5 to 10% of the total block size. Consensus here means that the attestations, your validated votes, but majority of it is this execution part, which is the EVM stuff. And then we cannot scale further unless we do something about this, right? And shout out to this site that Ethereum Foundation has made that just shows that the purple part is the execution part, the green part is the consensus part, and today most of the block size are dominated by the purple part, which is the execution part. So here is an Ethereum slot, right? Again, another diagram that we have 4 seconds, and the max we can do today in the spec is 1600 mil execution gas. That's the max. And then we can do 21 blobs. That's about 2.68 megabyte, right? We can exceed that maybe, but if we exceed the limit, that chances are it can go beyond the 4-second mark, and then the block can get reordered, or no one else can run a node, right? So now you guys are sharp. You guys probably are asking the question, why only 4 seconds, right? Because between 4 to 12 seconds, there's still 8 seconds left. Why can't we do something there, right? What are the nodes doing there? The nodes is doing something there. The nodes is aggregating all the votes together, right? And then, but then can we actually use the second half of the slot for execution for blobs, right? Wouldn't it be nice to essentially use the whole 12 seconds for bandwidth for compute, such that we can process more transactions, we can process more blobs, right? What can we do to get us there? So EPBS is in Shine proposed to build a separation. But you can also think about this as execution, payload, and block separation, right? The idea is not very new. It originated in 2021. Vitalik has written about that before, right? But the original version was that validators has to be decentralized. Builders are more sophisticated. They have the order flow. They have their special packing algorithm. So why don't we separate those two together as two different actors in protocol, such that this is a more efficient market structure, right? And then later, his proposal actually, instead of one slot, it becomes two slots because you need two attester votes to vote on the second part, which is not sustainable. You don't want to increase the slot time. We solved that by having another payload committee, such as a smaller size. We can fit within 12 seconds. But if you see the later proposal, which was proposed in Glamsterdam, we emphasize more about the key benefit being better slot utilization because of scaling. It wasn't so much about like we want to improve the market structure, which is still there. The benefit is still there, but the proposal becomes more like the scaling proposal, which we end up realizing EPBS is the least resistant way, the most efficient way we can do today to scale the execution, to scale the blob. And then it was finalized as a headliner last year. So what are we doing here? It's very simple. You separate the block from the payload. Today, block, payload are together. You separate them. You have your block, which has a commitment to the payload, and the payload is a separate network object. And then you have some testers, validators that votes that payload is arrive on time. So here is what an EPBF slot look like. You have a second 0, you're proposing the block. You have second 2, before it's the second 4, you were testing for the block. And then if there's enough attestations, then the builders will reveal its payload between the 5 to 6 second mark. And then there's another committee to attest for the timeless of the payload at the 7 to 9 second mark. And as you can see from here, kind of, right, the whole slot is being utilized. So what's the benefit here, right? Let's recap what the benefit is. Today, because of timing gain and everything, most validators, most nodes have 2 seconds to process the block. Now you have between 9 to 12 seconds to process the block, 9 to 12 seconds to download the blobs, right? Which means that as a attestation, you can get the head vote right more, the chance you see less reward. And it's even bonus, this is good for shorter slot time because when you reduce the slot time for the shorter, you want to utilize the whole slot. This is also good for ZK proving as well because now as a prover, you have more time to generate the proof. And this is what the EPBS slot looks like, right? Before, remember, we have 4 seconds and then you have just 2 brown lines, but now we're utilizing the whole 12 seconds. And what is really cool about this is that like you can play this trade-off game, right? Because blob is slower to download, but it's very, very fast to verify. Versus execution payload, it's slow to download, but it's also slow to compute and verify because that you actually have to process it. So you can kind of like do different deadlines. You can say, okay, as a blob, the deadline is the end of the slot, but as a payload, the deadline is the 9 second mark. So we can give 5 seconds to download and then another 3 seconds to verify. And most of this will come from testing to figure out what's the right trade-off is. So I only had 15 minutes, so I didn't really like cover like 90% of the other things. There are a lot of benefits beyond scaling as well, such that like what happens when you essentially allow the proposer and the builder to essentially sell and buy the block together. What happens if like that whoever proposed the payload, their identity is on chain, what can you do? What are the stakeholder impact, right? As a proposer, as a builder, or even as a relayer, like what changes in the EPBS model? Finally, what does EIP-7732 enables for us in the future, right? Because now we have this builder on chain. You can actually enable a lot more future roadmap iterations, such as like you can do the auction, you can do slot auction, for example. Instead of selling the block commitment upfront, you can just sell the whole slot, right? You can do MBV burn, for example. You can even lower the insurance that way. So yeah, this is all I have for today. I'm around, so feel free to ask me any questions. But this is coming this year, and hopefully we'll see another big increase in terms of gas limit and the blob. Thank you.